Hello, everyone. Welcome to my presentation. My name is Lihua Yao from Department of Defense, Office of People Analytics. I would like to acknowledge my co-author, Person Alarm, Jerry Lee, Oleg Molikov. The title of our presentation is An Evaluation of Twitter Sentiment Classification Methods. Background. Social media such as Facebook, WeChat, or Twitter have millions of people share their thoughts each day. Using the text in social media and then training a machine to understand the tone of the context is difficult but rewarding. Emotions such as happy, sad, proud, surprised, scared, angry, and disappointment, etc., can be detected through training the machine. Therefore, monitoring social media allows us to gain an overview of the public opinion behind the certain topics. Sentiment analysis refers to the practice of applying natural language processing and text analysis techniques to identify and extract subjective information from a piece of text. Understanding the sentiment from a piece of text can be a very powerful thing. For example, a merchant can quickly detect an unhappy customer and provide remedy to avoid reputation damage. Full problem statement. Our goal is to predict sentiment or emotional state of tweets using supervised classification methods. It is based on a Kaggle computation data for tweet text. The link for our data is provided here. The data has Twitter text and also have sentiment. For example, one of the Twitter texts is, "So sad, I'll miss you in San Diego." For the sentiment, there are three categories: neutral, positive, and negative. For the neutral category, the sample size for the trained data is about 11,000. For the test data is about 1,400. For the positive category, the sample size for the trained data is about 8,500. For the test data is about 1,100. For the negative category, the sample size for the trained data is about 7,700. For the test data is about 1,000. In practice, we may only be interested if there's an emotion or not. Also, since the sample size is not too big for the positive or negative category, so we combine positive and negative together as one category labeled as non-neutral. The sample size for the non-neutral category for the training data is about 16,000. For the test data is about 2,100. The processing pipeline. Start with Twitter text. We clean the data and also remove stop words. Apply tokenization. The most basic and initial step for analysis of natural language processing is keyword extraction. Without keyword extraction, it will not be possible to move any step further. One extraction technique we applied is RAK, which is also known as rapid automatic keyword extraction. For example, for Twitter text of value, "So good, I'll miss you in San Diego," the RAK extraction is "miss, too sad, San Diego." For text value of "I would have responded if I were going," the RAK extraction is "going, responded." So the RAK technique applied to the original tweet text, and the column of that is labeled as RAK extraction. For the two types of data, original tweet text and RAK extraction, we applied two feature extraction methods. One is called DTM, document term matrix. Another is TF-IDF, term frequency, inverse document frequency. For the three-level sentiment analysis, we used 4 statistical models, and we want to check which one gives better result. The first model is logistic regression. Logistic regression is a traditional standard approach that is often used for low-dimensional binary classification or regression, although it was extended to multi-level classification. This model is the most used model in our educational measurement. Second model is linear supporting vector machine. This model is a supervised learning model that analyzes data for classification and regression. It finds the margin of a hyperplane that separates the class of the data. It works best when the data has clear boundary between classes. The third model is multinomial naive Bayesian. It is a probabilistic learning method. This simple probabilistic classifier based on applying Bayes theorems with strong independence assumption between the features. Another model we applied is random forest. It's an assembled learning method for classification and regression. It draws random samples from the original data set based on bootstrap and builds multiple trees and then applies aggregation. The final class is the mode of the classes if for classification, or mean prediction if for regression. It focuses on prediction rather than explanation. Here we will talk about the classification accuracy. After the data transformation or feature extraction using DTM, DFIDF, the 4 statistical models were applied to the matrix of dimension about 27,000 and 1,000. The 1,000 is the number of features for the training data. Cross-validations were used in finding the optimal parameters for each model. The trained optimal model was then applied to the test data. The table lists the test score, and that measures the classification accuracy. We can see that DTM and DFIDF have very similar results for the 4 statistical models. And also, look at the right column for the test score for rig extraction. The results are very comparable with the original text data. So the test score from the original Twitter text and then the test score for the rig extraction are very similar. And overall, among the 4 statistical models, the test score for logistic regression is the highest. F-score for the 3-level sentiment analysis for the 4 models were also computed. We can see from the table that for positive category, the F-score are higher than the negative and the neutral category. And also overall, random forest has an average of higher F-score. For the 2-level sentiment analysis, we applied DFIDF for feature extraction, and we also applied BERT transformer. BERT is a bidirectional encoder representation from transformers. It is a transformed-based machine learning technique for natural language processing, pre-training developed by Google. After BERT transformer technique is applied to the text, the dimension of features reduced to 768. And the TF-IDF is also applied for the feature extraction for the 2-level sentiment analysis, which had 1,000 features. For the 2-level data, supervised learning using the 4 statistical models and the neural networks were applied. Fully connected neural networks consist of a series of fully connected layers that connect every neuron in one layer to every neuron in the other layer. Convolutional networks has been shown to be quite effective for image classification purpose. So in this paper, we applied the two neural network method in our data. For the BERT transformer, we applied three models, LR, LVS, RF, and then FCNN. For the TF-IDF feature extraction, four models, LR, LVS, MB, RF, FCNN, and CNN were applied. Here is the result for the two-level classification accuracy based on all the models and all the feature extractions and also BERT transformer. If you look at the bottom four lines for the BERT transformer, we can see the three statistical models and also the neural network FCNN, the test score for them after BERT transformer are higher than the test score for the DTM and the TF-IDF. And also, we look at the two blue circles. For the four statistical models, for the TF-IDF and DTM, we can see that TF-IDF had slightly higher test score than the DTM for the four statistical models. And also, the two neural networks, FCNN and CNN after TF-IDF, were not better than the other four statistical models. This bar chart visually shows the result of previous table. The blue bar is the test score for the training data, and we can see that random forest and the two neural networks had higher train score, and the test score for the BERT transformer are higher than DTM and the TF-IDF. And the neural network FCNN after BERT transformer gave very good test score. Let's summarize the result. So let's look at DTM versus TF-IDF. Although there are many references that shows that TF-IDF is better than DTM, however, in this research, we see comparable results for the two approaches in three class sentiment. TF-IDF has an advantage over DTM in situations where some features appear infrequently in document. Maybe the sample size for the training is not large enough, so there are not enough infrequent terms. Also, this sample size not large enough also confirmed by observing that in two class sentiment, TF-IDF was slightly better than DTM. Rig extraction. Results using extracted features are comparable with the full text tweet. Consider that rig extraction provides shorter words or sentences comparing to the original tweet. So in the future, we may consider using it to build dictionary. BERT transformer. BERT is a pre-trained machine learning transformer that not only takes into account the context of each occurrence of a given word, but also reduce the original larger feature dimensions to 768. Models trained on BERT transformed data had increased test scores. Two-level classification yielded better scores than three-level classification. We hypothesized that larger training size would improve test score for three-level classification, and also result for the TF-IDF would improve with the larger training size. Summarization for the four statistical models. Random forests consistently score high on train and test data. This finding makes sense. Random forests emphasize on feature selection and weigh certain features as more important than others. It does not assume a linear relationship like the regression models. A random forest takes random samples, forms multiple decision trees instead of just one. In our best scenario, we are taking average of 110 tree samples. The just regression accuracy is consistently better than supporting vector machine. It is the best in 3-level sentiment classification. We notice this behavior across all our experiments consistently. This finding makes sense given that typically the just regression is used for binomial and multinomial classification purpose, while supporting vector machine model tries to find the best margin that separates the classes and reduces the risk of error on the data during the process. So perhaps this set of tweet sentiment data does not have as clearly demarcated decision boundaries with large margins for support vectors. For TF, IDF extraction data, neural networks, FCNN, did not perform better than the 4 statistical models. For BERT transformed data, linear supporting vector machine had the best test score. The just regression and the linear supporting vector machine had low train scores of 0.77. However, the test scores were as high as the train scores. Increasing the sample size might improve the results even more. Fully connected neural networks, FCNN, had the highest train score of 0.99 and the high test score of 0.75. For future work, we would find more data to increase the sample size for the training. And BERT transformer is very promising. Build Twitter library, apply word embedding layers for deep learning with our pre-trained model with the dictionary. Investigate the effect of part of speech tagging on Twitter sentiment classification. In this paper, multinomial naive Bayesian performed the worst. Prior expert probability assignment for features plays an important role. It might be a good model if we apply part of speech tagging on the Twitter sentiment classification. Thank you. If you have questions, feel free to send an email. Here is my email information, and the code for this paper can be found at this link. Thank you.